Didn't mean to leave us on such a cliffhanger on that last video. Not sure what happened, but hopefully no kinks going on from here. So we were asking, what was the relationship between the blue arc and the pink arc? Together, they make up the whole circle. And we know that there are 360 degrees in the whole circle. So if arc BAD is 200 degrees, that must mean that arc BCD is 160 degrees. Because we know if you take 360 minus the measure of arc BAD, which was 200, you get 160. Okay, well, how is that going to help us? BCD, that arc is the intercepted arc for angle BAD, for angle X. So we know that X is going to be 1/2 of 160. So X is going to be 80 degrees. Okay, so how does that help us with our special relationship for our inscribed angles? Opposite angles in inscribed quadrilateral are going to be what? Well, what's the relationship between 100 and 80? They are supplementary, which is pretty cool. Now, we don't know angles B and D here. However, if you remember, the angles of a quadrilateral always sum to 360 degrees. So if these two add to 180, the other two also have to add to 180. So we might not know what they are individually, but we know together they add up to 180 degrees. So remember what you're going to add to your toolkit. This definition here, this picture might help. And then also the fact that they're supplementary. Okay, so as an example for your toolkit, if you're using this picture, you could say that the measure of angle A plus the measure of angle C is 180 degrees. Also that the measure of angle B plus the measure of angle D is 180 degrees. Now, I want to take a little bit of time and prove this to you. I won't ever make you do this on your own. I just want to kind of show you why it's cool, how you can do this for an arbitrary inscribed quadrilateral. So if we're going to call angle ADC, let's call it X. Okay? If I'm calling angle ADC X, and that is an inscribed angle, then I know that its intercepted arc is going to be double that. So let's call arc, the measure of arc ABC, that's going to be 2x, because the intercepted arc is always double the inscribed angle. All right, so then let's look now at the opposite angle, because our goal here is to show that the opposite angles are supplementary. So if I'm looking at this angle right here, and its intercepted arc, we can say that the measure of arc ADC is going to be 360 minus 2x, because it's what's left of the circle. This is like what we did up here in the previous example. This one just was using exact numbers though, and this is just using a generic x random variable value. So then if we want to find the measure of angle ABC, as an inscribed angle, I know it's going to be half of the arc that it intercepts. So let's distribute that 1/2, clean this up a little. Half of 360 is 180. Half of 2x is just x. So this is 180 minus x. And our goal is to show that these two angles together are supplementary. So let's add them together. If I add x to 180 minus x, the x's cancel, right? X minus x. And I'm just left with 180 degrees. So that kind of proves that no matter what the values, my opposite angles in an inscribed quadrilateral will always be supplementary. Okay? So I'm going to walk through example 8 with you right now, and then I'm going to have you press pause and you try example 9. So we're looking at this inscribed quadrilateral, and we're trying to find the 2 missing angle measurements as well as an arc measurement. So we want to find measure of angle D. Well, angle D is opposite of angle I. So we know that the opposite angles in an inscribed quadrilateral are supplementary. So if I just do 180 minus 117, I'm going to get 63 degrees. Same thing here. If I do 180 minus 85, I will get 95 for angle B. Now the measure of arc BDR. So I go from B to D to R. Color really helps me when I'm seeing this. Look at the inscribed angle that this came from. It came from this angle I right here. And angle I measured 117 degrees. So if I just do 117 times 2, that's going to get me 234 degrees. All right, press pause. See if you can do example 9. Now that you've tried it, let's see what we got. So angle D was opposite of 45. 180 minus 45 is 135 degrees. Angle W is opposite. It's hard to see opposites because it's like, you'd think it'd be I, but basically it's the one it's not next to. It's next to I and D, so it's not next to L. So that's what makes it opposite. So W is across from L. 180 minus 109 is 71 degrees. Then we want to find the measure of arc DWL. So DWL, that's a big one. So that arc comes from what? Oops, I went over the wrong one. DWL. What is that going to be? Looks like I made a typo. Sorry, y'all. I wanted you to find the measure of arc WIL, not DWL. So WIL is the intercepted arc from this angle D right here, because D goes to W and to L. And so if I just double 135, I will get 270 degrees. Sorry about that. For your exit ticket today, what you're going to be doing is answering some questions about inscribed angles. Then you're going to fill in your answers on the Google form that goes with it. If you have any questions, let me know. Hope you're doing well. Again, sorry for the mistake on the video. See you guys later.